The roadmap for this talk is going to be the following. I will start by talking a little bit about the background and motivation for developing this annotation scheme. Then I will talk a little bit about some proposals of multi-layer annotation schemes that are used to in other data sets. And I will describe the annotation scheme, not in much detail, but enough for you to understand the complexity of the semantic annotation we have been doing. And I will give you an example or two if you need, but we can discuss it later. And then I will move on to see how we have been using these annotated data to formally represent, and also to extract information from narratives and, for instance, to different kinds of visualization. So let's start with the background and motivation. We have been working with narratives, and as you know, here we use narratives as a plot that is normally characterized by a succession of events, and also that involves participants, different types of participants, and these succession of events occur in a time, in a place. And this narrative, we can find this kind of narratives in many domains. For instance, the literature, maybe it's the most well-known, but we also have narratives in journalism. For instance, news normally have a story behind, so this is a kind of narrative. We also have narratives in the health domain. When you look at clinical reports, for instance, you can find different kinds of narratives of the story of the patient and the disease, and we also have been working with that. And also finance, the news, for instance, related to finance and economy, also tells stories, for instance, about the increase and decrease of prices. So in all of these domains, we find these narratives, and we think that it's important to develop some automatic methods of extraction of all this information that can be relevant for different purposes in these domains. However, extracting information from these narratives is still a very challenging task. Of course, there are different steps to extracting information. We can start with events, the participants, the times, the places, and still some are more developed than others, but still they are very challenges as a whole. And also there is the problem of a lack of annotated data sets that can be used to train models to extract that information that we need. And the narrative annotation efforts are really complex, because if we want to extract all the information from the narratives, we have to have a densely annotated data set, a semantic annotated data set. And this, if you work with annotation, you know that it's a very challenging task, okay? I'm not going to talk a lot about the different phases of extracting narratives, but if you want, we have a survey on narrative extraction that was published 2 years ago in the Artificial Intelligence journal. So it was in this context, it was related to these problems that the project Text2Story was designed. This project, the main objective of this project that our team started working in 2020 was mainly to establish a data set, and then what we wanted was to extract the participants from the different narratives that compose the text from the data set, the events, temporal expression, and also the different kinds of relations between events and also between the participants. And then we wanted to represent the information that we annotated formally, and I will let you know what formalism we use. We wanted also to be able to represent the information in different visual formats. And you may ask, why do we need this? Well, the fact is that nowadays we receive a lot of information. For instance, journalists receive a lot of information daily, on a daily basis, right? And so they don't have time to go through all the news and all the information that they receive. And for instance, visualizations would be an easier way for them to access that information. And this was the main objective of the project Text2Story. From the project Text2Story, we designed another project that is called Project StorySense. And in this case, we wanted to go further into the semantic layers of the narratives. In fact, we wanted not only to continue doing the work from Text2Story, but also to extract, for instance, causal relation between the events, right? Because it's also a very relevant part of narratives. And also we wanted to be able to represent narratives inside narratives. If you think of a news, for instance, of a piece of news, you see that there are sometimes the main event, but inside the main event, there are also other stories that are embedded in that story. So we wanted to be able to distinguish and represent the different stories. And also, we wanted to be able to link the participants, the events to knowledge-based and also to ontologies. So the project that we are now developing this project, that's the main goal of the project, to go further into the analysis, the semantic analysis, and also to try to establish an ontology of a narrative, of a typical narrative, according to different types. So, of course, that to extract, represent, and visualize narratives, we need annotation, right? And we need an annotation scheme. And when we started working on this, we thought, well, we are working with news, so we have to develop an annotation scheme that is able to represent the main news features. And as you know, news typically reports on current events, and they involve one or more entities that occur in a given time and place. We wanted to work news that told stories, right? So we selected news that had a narrative nature, because that was the main objective of the project. As you know, also, typically a news has to answer to questions like who, what, when, where, why, and how. Okay, so we had to have our annotation scheme able to represent this key information. And the news also established different types of relations between events, between times, between time expressions, and other kind of relations. So we had to develop a multi-layer semantic annotation scheme. And we had to take into consideration the main features of news and the information that we needed annotated so that later on we could extract it automatically. For that, we had to combine different layers, right? Because we had the temporal layer, the referential layer, the spatial layer, also the semantic role layer, and discourse relation. And we thought about how we should do this, and we wanted an annotation scheme that would be interoperable and coherent. Okay, so we didn't want to take the tags for temporal annotation from a proposal and then go to another proposal and take the necessary tags and attributes for referential. We wanted something that would be coherent, right? And also that would be language agnostic. And so for that reason, we thought of ISO 24617. This ISO is a proposal for a semantic annotation framework, and it is divided in several parts. Right? So we have a part for time and events, and we have a part for reference, and so on and so on. For these particular projects, we used parts 1, 4, 7, 8, and 9. Okay, so these were our choice. And why did we choose working with ISO? Well, when we look at related work, and there is a lot, as you know, during the last few years. There has been a significant proliferation of multi-layer annotated data sets, and there are different proposals. You may know some. For instance, we have this mask that is a manual annotated subcorpus. We also have the Groningen Meaning Bank, and for Portuguese, there is, for instance, this one, Scintille Deep Bank. So we look at these ones when we were surveying the relevant literature, and we found, of course, different proposals. But when we look into the different proposals in more detail, for instance, like this one, Mask and the Groningen Meaning Bank, what we observed is that these were corpora that were annotated in different layers, but the different layers were not connected between them. And also, there was some information, semantic information missing. For instance, in this case, we didn't have information related to space, for instance, right? And also, if we look, for instance, into the Groningen Meaning Bank, that it's a well-known data set, it's also a very complete annotated data set, but when we look closely, we see that it's missing some information that may be relevant, for instance, to extract temporal relations. Because, for instance, they only use DRT, discourse representation theory from Camp and Weil, to represent events and states, and they don't annotate specific properties of events that can be relevant for establishing temporal relation and discourse relations, for instance. So we also left this out. And for Portuguese, there are not many, as it may happen with the Polish also. There is this one, Scintille Deep Bank. It's mainly annotated with semantic role labeling, but once again, it lacks some annotation of information that is relevant to characterize narratives. So, because of this, we thought of developing our own annotation scheme, having as a base the different parts of ISO 24617. To develop the annotation scheme, we had to follow what is called the MAMA subcycle. I don't know if you heard about it. Of course, first we had to model the scheme, and then we had to try it out, right? So we did some annotation in the training data set. Then we evaluated how well it worked, and we did the necessary changes so that it could represent more completely the information that we wanted to annotate. And of course, after the revision, we did the subcycle again. And we did this as many times as we had to do until we were satisfied with the annotation scheme. And this took us almost 1.5 years of the project to develop the annotation scheme, the first phase of the annotation scheme. So presently, we have an annotation scheme with these with these 5 parts. As you can see, we have the temporal layer, the referential layer to annotate the participants. We have also spatial information, the semantic role labeling, and also discourse relations. I say that presently because we developed this annotation scheme by the different phases. In the first phase, we only included temporal, referential, and semantic role labeling. And then we added the spatial information. And finally, more recently, we added the discourse relations layer so that we can represent causal relations in a more coherent manner. So, what happens with ISO Part 1? This part of ISO proposes a full-fledged markup language for a fine-grained annotation of temporal information. Here we can annotate events, time expressions, and the relations between these. The referential part enable us to represent what type of participants are part of the story and what are the main linguistic characteristics of the expressions that represent those participants. Also, we are able, for instance, to represent anaphoric relations between the different participants with what we call objectal links. Regarding space, we have a whole set of different tags and attributes to represent locations and also the relation between the object that is being located and the location itself. The semantic role labeling gives us a list of semantic roles that we use also to establish relation between participants and events. And finally, we have discourse relations that allow us to represent meaning relations between different situations represented also in the news. So this is the different parts that compose our annotation scheme. I must tell you that these parts were created separately, right? As you can see by the, I don't have here the dates, but they were published in different years, some 2, 3, 4, 5 years apart, right? So they were never before worked in the same annotation scheme. They have been used separately. For instance, the temporal part is very well known. We have time chisel, everyone knows that language. But all these parts have never been combined into a sole annotation scheme. And of course, this, because it had never been done, raised some problems. We had to really harmonize all the parts into this coherent, not overlapping annotation scheme. And I will talk a little bit about the problems, some of the problems that we had to solve. So, let me just show you very briefly how this annotation scheme works. We have two types of entities, two types of structures, the entity structure, and then we have the link structure. The entity structure includes different types of entities: events, participants, times for temporal expressions. We have also measures for quantifying expressions, spatial relations to represent locations, and we have these more recent tag that is situations that is used to establish discourse relations, and we had to project this entity structure because otherwise we wouldn't be able to link them, okay? And so the link structures must have as a base entity structure, okay? So what type of link structures do we have in our annotation scheme? We have temporal links, of course. We have spectral links. These two allow us to represent the temporal and spectral properties of events. We also have subordination links that allow us to capture some subordination relations between sentences, like John bought a car to travel to Portugal. Okay, to travel to Portugal has a subordination link to bought a car, right? Purpose. We also have objectal links that are established between participants. The spatial links I told you about, they are established between the object that is located and its location. The semantic role links are used to establish relation between events and participants, and finally discourse relations. So these are the main scheme of our annotation, and for each of these structures we have different attributes with different values. I'm not going to describe them all here, of course, but for instance, for events, you can see that we have to annotate the class, the type, the aspect, the part of speech, modality, mood. In this case, we used most of the attributes that were proposed by ISO. We only had to adapt due to language specificities. These ones, modality, because we had to insert the modal values for Portuguese, right? And also we added the attribute future to the mood, because in Portuguese we have this future with the modal meaning. But for most part, we used what is proposed by ISO. In terms of temporal expressions, we did an annotation that's very simple. We use the type, if it's a date, a time, a set, or a duration. We annotate the value manually. It's not the best option. We are now thinking of a way to predict the different values that dates can have, and then try to do it more automatically. Because, as you know, for computer science, it's not very good to extract information that is written manually in a box, right? So we are trying to do that. We have temporal function of the expressions, temporal expression. Normally, the publication time, as you know, in news comes at the beginning. So we annotate that as publication time. And then we also establish the anchor time. This is important because, for instance, in the news, if you have today someone assaulted someone, this today has an anaphoric link to the date that it is at the beginning. So the date works as an anchor time for me to interpret today. Otherwise, I wouldn't be able to do it, right? In terms of participants, we not only annotate linguistic information, but also their meaning in terms of discourse. So we have lexical head, if it is a noun or a pronoun, and then we have the domain, if it is a set, an individual, or if it's a massive noun. And for these types, the ISO doesn't propose any types. We went and collected some of the most used types in tasks, like to name entity recognition, right? So we went and shows what are the most used, like person, organization, object, and so on. When we had in the space part, we had also to add some values for places like water, country, district, and so on. In terms of the other entity structures, we also have measures, and in this case, we annotate everything manually. It's not the best thing. We are trying to solve that. And for spatial locations, we have values for dynamic locations, like in the direction of, or static locations inside of, and these are the different values that represent different types of locations. Finally, in terms of links, you can see here we have different values for the links that I told you about, right? The temporal relations before, after, and the objectal links. We have objectal identity when the same participant is being talked about in the news. So we identify this anaphoric relation in this way. And in terms of discourse relations, for now, we are just annotating poles, right? Because we want to extract causal relations. And we have a PhD student working only on this. In terms of space, we also have different values that I'm not going to talk about, but these are the relations that we establish. And this is also a very complex annotation, the spatial relation. So this is all the tags, attributes, and values for our annotation scheme. And we establish for our annotators different stages. We have done some experiments to see what works best. For instance, if it works best annotating all the layers at the same time, or it would be better to do it by stages. And so we established that it's better to annotate first events, then the time expressions, and then the temporal links and subordination and the spectral links. Then we move on to the referential layer, where we annotate the participants and the objective relations. Then we move on to semantic role labeling, then spatial information, and finally the annotation of discourse relation. We did these experiments where we measured the time that the annotators took following this procedure or doing everything at the same time, and it was more productive this way. So in our annotation scheme, we established these phases. Okay, so now coming to the problems. As I told you, this was not, this ISO was built separately. There is one part 6, that talks about the principles of this annotation framework, and they cover some of the problems that we may encounter when we try to combine the different parts. But again, this is the first time that so many parts are combined together, so they don't cover everything. And I can tell you that there were problems like, for instance, there was some overlapping between the different parts. In the different parts, there were tags that were used to annotate the same thing, the same information. So in those cases, we had to delete some of the tags. So between the event and the other event. Okay. Also, for instance, in part 1, the ISO says that an event can be represented by a noun, a verb, or a preposition, right? And part 8, regarding discourse relations, says that argument of a discourse relation must be an eventuality that is represented by a clause. So these two are in conflict, right? That's why we decided to introduce a new tag that's situation, and the situation can be a clause, and that way it can work to establish relation between discourse relations. Also, I talked about the removal of some conflicting tags, and the problem that we are having with the annotation tools is that we can only establish and mark, we can only annotate what is called explicit lexical expressions. But in Portuguese, for instance, we have the subject can be omitted. I think in Polish you also can do it, right? We can omit the subject, but still we needed to annotate that information because it's relevant. We needed to know if the null subject is a participant that is mentioned earlier or not. But in our annotation tool, we weren't able to do that. And for instance, the part of space also stipulates that are what we call non-consuming tags, the ones that are don't have an explicit markable, but we weren't able to also annotate those because our annotation tool doesn't allow it. What is our, I'm going to talk about a little bit about the annotation tool. We are using RAT, I don't know if you know RAT, but now we are changing to another one. Okay, so let me just show you a very quick example. This one was created by us, but it was a base from news that we read. So scientists that were studying the eruption of a volcano of Iceland decided to use the lava expelled from the crater to roast sausages. Okay, so let's focus on the bold words and expression. So the first part, what we did, we had to annotate events and all the attributes of events. For instance, decidiram, decided, is occurrence of the spectral type transition. It is in the past, it's perfective, and it is positive. And we did the same for all the events like used, and also for temporal expression, in this case, this Friday. Okay, it is a date, and we annotated the value of the date and the anchor time. Okay, the next step was to identify temporal relations. Okay, so we see that, for instance, you decide is included in the time expression this Friday. Right. The next step was to annotate the participants. Okay, scientists. So scientist is represented by noun. It is an individual, a person, and we have the other one, lava, and so on. Next, we had to represent objectal relations between the participants. So we can see here that lava is part of, crater is part of the volcano, right? So we establish these objectal relations between the two participants. And finally, we establish the semantic role label. Right? So we see that, for instance, participants is the agent, scientist is the agent of the event, decide, and P4 in the lava is the instrument of event 4 that's used. Right? Okay, so this is the representation of the annotation. We do the annotation in red. You can see all the links here. It's sometimes very difficult to read because we have a lot of annotation and a lot of links. Now we are changing to Inception. Do you know Inception? Okay, so we are changing to inception, and we are programming it in a way that it would be easier to annotate, because we have a scroll down where we can, for instance, choose a participant, and then we choose the link that we want and gives us all the attributes. And also we are able to hide the annotation. For instance, if we want to look only at the annotation of one specific event, we can choose to do so. Okay? So it's easier to annotate and easier to look at and to verify the annotation. Okay, so moving on to the last part of my talk, the formal representation and visualization. The part of visualization is more computer science. I'm going to talk a little bit about it, but I think I won't be able to answer to very difficult questions, okay, about that. So the idea was, we had to, with the annotation, we were able to identify the main elements of the narrative, right? And their attributes, and also the semantic links between them. What we get as a result, we have structured information that can be represented in a formal language, and also that can be used to produce visualizations, okay? And in order to do that, our colleagues from computer science developed what is called breadth to vis, okay? From the annotation to the visualization. And it is a pipeline that allows us to represent the information that is annotated and generate different types of visualizations, okay? So this idea, we have two papers published, one 21 and now more recently 24, in my colleague, Evelyn was there to present the work. So how does this work? I'm going to explain very briefly. So we have this breadth tool, right? And then we have the annotated file, the one that I show you in the example before. And then we represent it using the principles of discourse representation theory from Camp and High from 1993. I don't know if you know this theoretical proposal, but it is a semantic proposal where they stipulate a representation of the semantic information using first order logic in what we call discourse representation structure, DRS. So the first module from this pipeline is breadth to DRS. So we have these annotation files that are generated by breadth. We parse them and create these DRS representations, okay, for each new story. And then we have the second module that is from DRS to visualization. So there is this web application that produces visualizations of the original news text. So let me just show you. This is how is represent the formal representation of the annotation. So these are called the DRS. Discourse representation structures, you can see here. And we have, for instance, the participant where it was 92, and the lexical head, and then the different links that are established between the participants and the events and so on. For now, we were able in this pipeline to generate two types of visualizations. This one, it's called knowledge graph, as you know, and we are able to establish, you are not able to see it very well, but here we have the focus on participants, okay, the men, and then here you can find the events in which the men participates, okay, and we establish between the relations between men and the other participants in terms of semantic role-label. And the other one is the message sequence charter, where we also have the participants before in the first line, and then the events in which participates. For instance, the man, the second participant, assaulted, robbed someone in an avenue, right? And then we established, and this was generated based on the formal representation of the DRS. More recently, we also have been working what we call these bubble representations that also allow us to represent the embedded stories that I talked about before. So each bubble is an embedded story, and each embedded story has the different events that are part of that story and the participant of the story, the main participant. Based on this annotation, we also we are now working on representing timelines and temporal information. We have been representing, for instance, temporal relations between the different events. The events are inside the boxes, and then we establish the different temporal relations between the different events. Also using the bubble diagram, also with the different relations between each embedded stories, the temporal relations. Okay? So, to finish, what have we accomplished so far? We have accomplished a multi-layer annotation scheme that combines into a coherent manner all 5 parts, the 5 parts of ISO, and it is built in such a coherent way that we are able to represent the information that is annotated in a formal language, in this case using discourse representation structures. Also, we have built a corpus, a data set, and for that we first started by collecting news from the biggest news agency in Portugal, that is called Lusa. We were able to establish an agreement with them. It took us almost 2 years, but we were able to do, because I don't know if you have this problem here, but they don't allow us to use data, even it's on it, and they publish. So we had to have this formal agreement, and now we have. So we first we selected some news that were given by them. First we established the criteria for the news. We didn't want very lengthy news because of the annotation overload, but we also wanted, we did a first query, and we identified some features of narratives that could help them, Lusa, to send us the most adequate text. So, for instance, we saw that if the topic was crime, the natures would be more related to stories, right? Because they tell us a story, how someone murdered another, how he escaped, and how he was arrested, and so on. So we gave them some keywords for them to give us the kind of text that we wanted to work. So now we have Text2Story Lusa with 357 news articles. Until now, we have been able to annotate 117 news articles, fully annotated with the scheme that I just showed you. And these have been validated. We have been working with some annotators, but we also tried to do some inter-annotator agreement to validate not all, but a sample of the annotated data. Now, in Portugal, we don't have a lot of funding. And for instance, regarding annotators, we had a scholarship for one, but now we are trying a different strategy. We are, me and Antonio, our developer, another colleague of ours, are working on a school for annotators. And so we invite some students of ours to participate, and they really like it. We were surprised, but they are working for free. We don't pay them. Of course, then oh, we have no money. But of course, then they will have some documents saying that they are participating in the project, but they don't mind working for free. I need some annotations done for September, and I talked to some if they would be willing to work throughout August. And they said yes. One of them told me she didn't have a lot going on in August, so she didn't mind doing the annotation. So it's good. But because for this kind of work, we need a lot of annotators. By ourselves, we're not able to do everything. So now we have these loose annotated data sets, and we have 50,000 annotated elements. So you can see the dimension of the annotation. We have here the numbers. We have about 14,000 entity annotations and 40,000 link annotations, so it's a lot. When we were presenting this in SE this year, someone asked if this data set existed in other languages. Because they would be interested in looking at the annotation. So we thought, well, we should do this. And now we have funding for a translation project because with the resources from Google. And we are translating our data set, the original data set, to other languages, Chinese, German, and so on. And we will do what is called aligning of the annotations in Portuguese to the other languages. We have a PhD student that developed an aligner to be able to align annotations from one language to another. Of course, that after we will have to validate this manually, but we hopefully next year we will have our annotation, our annotated data set for other languages also. I will translate to Polish, but we don't have Polish students working with this. Okay, so this also this annotation scheme has been proved to be able to be used in another languages and journals. We have also tried other narratives, for instance, literary narratives. We are going to present a paper in October with an experiment of annotating Harry Potter. A part of Harry Potter, not all, in European Portuguese, Spanish, and English. And we, of course, there were some adaptations that we had to do because of the language specificities with English, for instance. Now I have a master's student that is working in clinical narratives, and she's going to use our annotation scheme, but she will have to develop what we can call a specialized branch of annotation to be able to capture more information related to the health domain. For instance, regarding events, here we have different classes like occurrence, reporting, but for medical data, we need to know if that event is an exam, a treatment, and so we will develop also this specialized text for that. The same will happen with the financial narratives that we are working on also. We feel the need also to add more informative text regarding events and also participants. And last, this multi-layer annotation scheme, and in particular our dataset, has been used to develop different experiments regarding NLP tasks. Now we are in the process of training a model to automatically identify events, participants, and discourse relations. And the first experiments that we did have been quite successful, and it has been trained in our annotated dataset. And also some colleagues have tried to compare the GPT models on narrative entity extraction based on the training that they did with our annotated dataset and our annotation. So these are some outcomes that have been developed due to the participation of our team. These are Alipio is the main researcher, and Ricardo Campos also. They are computer scientists. And then we have also linguists, me and Antonio, and some students working with us also. So that's all. Obrigada.